This is Chapter 3, Ratios and Rates, and this is 3.1, Ratios. A ratio is a comparison of two quantities. It can be part to part to whole, or whole to part. And they may or may not include units. Part to part, if we were talking about students in the class, part to part could be comparing girls to boys. Part to whole would be saying how many girls compared to the whole class. And whole to part would be saying out of the whole class compared to girls. So, these are a few ways that we can say ratios, or if you see these words you might recognize that we're dealing with a ratio. We would have 6 cats to 4 dogs, 4 cats, 6 cats for every 4 dogs, 6 cats per dog, 4 dogs for each cat, 4 dogs out of every 6 pets, and 4 cats out of 8 pets. So if you see any of these keywords, you would just need to know we're dealing with a ratio. And we could write them as A to B. Most commonly, and the formal way to write a ratio is A colon B. We would read that out loud as A to B. Or we can represent a ratio as a fraction. So we're going to write the ratio of the coins, 2 pennies compared to 3 dimes. That would be 2 to 3. 6 nickels to 4 pennies is 6 to 4. 3 dimes to 10 coins is 3 to 10. And if we are dealing with the value of the ratio, that is the number, the fraction, A over B, associated with the ratio A to B. So if it's talking about find the value, you're finding the fraction. So if we say the ratio of socks to shoes is 3 to 4, that's 3 socks, 4 shoes, because it says socks first, then shoes. So this would mean the number of socks is 3/4 the number of shoes. If someone else has twice as many socks as shoes, they have 2 socks for every 1 shoe. So that is 2 over 1. And equivalent ratios are 2 or more ratios that describe the same relationship. If 2 ratios are equivalent, you can multiply each quantity in a ratio by the same positive number to get the second. So can we take 2/3, 2 to 3, and make it into 8 to 12? If we multiply each number by 4, I get 8 to 12. If I could also go from 8 to 12 down to 2 to 3, I could go either way. Now we are going to determine whether the ratios are equivalent. If we have 4 to 7 and 12 to 21, can I turn 4 into 12? I would multiply by 3. And to turn 7 into 21, I would also multiply by 3. So since I can multiply by the same number, I would say yes, these are equivalent. For 6 to 5 and 18 to 10, to turn 6 into 18, multiply by 3, to turn 5 into 10, multiply by 2, and these are different numbers, so no, these are not equivalent. The equal sign with a slash means not equivalent. And 18 to 14 and 3 to 2. To go from 18 down to 3, I would divide by 6. To go from 14 to 2, I would divide by 7. So since, again, these are different, the ratios are not equivalent.